we're planning ioRaptor as the first agile development toolchain for constraint devices and for IoT solutions. And why do we think that it's time for a new IoT development stack? We want to increase time to market and improve ramp-up times, especially for new product developments. So whenever you want to start a new product development, you typically have to select hardware, you have to do workshops to find out what to build, how to build. And we want to support developers and development organizations to do this in a better way and in a faster way, to let them improve, especially the ramp-up time when starting something new. The second reason that we see is that we would like to incorporate some of the best practices from the internet and web industry that we have seen during the last decade, among which are, of course, test-driven development, that you are using unit tests and integration tests in a highly automated way and let the process to writing software be guided by that test-driven way, as well as continuous testing and integration, especially continuous integration where your software is not built on your local machine but on some build server and automatically tested, and test results are automatically forwarded to the teams and to a dashboard so that everyone can see what's happening. And this has very much to do with automation, that these build processes are not triggered manually anymore and inspected manually anymore, but are highly automated. And we want to integrate cloud-ready approaches because this is one of the major factors to increase time to market and to improve your ramp-up time by just taking solutions that are already there and leverage them. We want to build a foundation for agile development teams, as we depicted in the second trend. It's likely that companies building IoT solutions will do this with different teams, and these teams have to work together. They have to collaborate in a very efficient way. And that's what we learned through the agile history. Yeah, and in the end, improve the confidence in the IoT product development process. And that's important. That's not only for the developers who would like to see, oh yeah, my code is running and it's the tests are green and stuff, but also managers would like to look at a dashboard and see where they stand regarding the overall product development process. And these are the reasons why we think that it's time for a new IoT development stack. So do we have all of that in our company in software that we've written? No, probably not. But we know which modules there are that should be part of that new development stack. And first is, of course, IDEs, integrated development environments. That's the core center of developer productivity, where you have a sort of text editor with code highlighting, syntax highlighting, and injections, and modern plugins that help you with the various languages that your stack comprises of. There are a bunch of very good IDEs around, both open source and commercially, for a whole number of languages. And there is a new category of cloud-ready IDEs. So that's an IDE that runs in your browser, and you're working remote together with your colleagues that are located on different parts of this planet, and you can co-work together. And we wanted to know if that is possible with embedded development, and yes, it is. Second is code management for IoT teams. In the end, that's source code management systems. This is nothing new when you're in the web industry or in the internet industry, but maybe for some smaller shops doing embedded development, This could be new, as maybe smaller shops are used to just store their code on some hard drive. And of course, when sharing this with others, with other teams, you definitely have the need for a good code management and good source code management tools. So that's another module. A third module is embedded platform management. And yeah, this goes a bit more technical into the embedded field. You probably know when programming for embedded, you need a compiler for the target platform that you have. These are typical cross compilers, and you need the right linkers and the right debuggers, and you need to flash your firmware to the device and attach debuggers of different kind. And ideally, this has to integrate with your IDE as well. And when changing the underlying hardware, you typically need to change your embedded toolchain as well. And there are a bunch of management tools for managing these toolchain tools. And yeah, we've been looking at quite some of them. And so we think this is a module here in the ioRaptor as well. Automated unit testing, automated end-to-end testing. We believe that this should be an integral part of the software development process. Without automated testing and automating the processing of these test results, there is not a high confidence in the code that you can produce, because you have to do everything manually, testing manually and running tests manually. This takes a lot of time, and this is prone to error. And whenever automating this, you can only win, in our opinion. So this should be an integral part of ioRaptor as well. Same as with continuous integration. This is the heart of a modern build tool chain. Everything should be automated and concentrated in a CI, continuous integration server. We're fans of a model-based code approach. What do we mean with that? We think that you should not implement individual functionality over and over again, but move the aspects of this out into models which describe the functionality, and use, well, at least in parts, code generators to generate parts of your code. The idea is old, but we think that during the lack of libraries for embedded, or the constraint or the space constraints that we have on small devices, we think that model-based code generation could be a good approach to that. For example, building APIs for devices, or for example, building code for state machines out of state charts. That's one example. Backend integration. Typical IoT solutions send off their data to some form of cloud backend. Wherever this may be located, it's in the cloud, but typically belongs to some sort of vendor with their distinct APIs and SDKs. So having the right SDK and installed automatically, for example, makes it easier for developers to start coding the backend integration. Architecture and code documentation. Well, this has largely to do, in my opinion, with the agile team approach. If you're working in larger teams, so plural teams, you have to share the ideas and the current status and documentation about code and about the architecture of what you build between these teams. You have to speak about the right things on the same level with each and every one. So documentation is also an integral part of this. And yeah, of course, teams have to work together, and there are excellent tools for that to support an agile development process. So we think that tooling for the process itself should also be part of that. So these are the modules on some form of generic level. And behind each of these boxes, we can typically find at least one, probably dozens of tools that support the goals behind these boxes. Now, what is the functionality of ioRaptor about? So some sample features are, or could be, you can find the tools for the aspects of the development that you're looking for. For example, if you're looking for IDEs that support MicroPython, or for cloud IDEs that integrate with, say, Platform.io, or for IDEs that support your kind of hardware and your kind of chipset. That's a question that you can sort of ask the ioRaptor and get help there. Or find the right CI server to be put in your environment. Or find a tool for managing your agile process. So it's about locating tools and finding tools. It's also about finding information, finding documentation and tutorials to get you up to speed, to increase ramp-up time. That's also a very important aspect. It's about searching for these tools by some sort of lateral aspects. Say, I want to have a complete tool chain for all of these modules, but they should be fully open source. That could be one question to the ioRaptor. Or I want to have a tool chain that works with a given backend from a cloud vendor and the hardware that I have. Maybe another question. And we plan to do this through a communicative user interface. We'll talk about that in a short time. It could be well suited to complete the tool chain that you in your company might already have with some sort of missing pieces. For example, you have everything, but not continuous integration for your embedded projects. You could search for integration servers and just adding it. You don't need to install a full-blown tool chain that the ioRaptor might suggest, but also individual parts from some of the modules only. The ioRaptor should allow to download the tools that you choose automatically, install them automatically wherever possible, and also check the installation success. And some tools might need a registration for third-party vendors. And to simplify things, we would also allow a registration through your ioRaptor account for selected products. So how does this work together? Little picture about the architecture. ioRaptor is essentially a desktop application. It's written as a cross-platform Qt application, which runs on Windows, on Mac OS, and on Linux as well. And we have a small demo in a few minutes' time. And yeah, you start on the application, and it should allow you to place questions, find tools and stuff. And where's the data, the metadata about all these tools located? Something that we call the ioRaptor registry. This is a web-based service. And the desktop app queries the components from the registry and allows you to browse through all components and find the right stuff that you need. And the registry essentially is formulated in JSON documents, which live on GitHub. So that is something that could be open to contributions, to participation. So for example, if you have a tool where you think that might fit in here, this can be integrated in the registry. And it's on GitHub, it's open for everybody to see. The ioRaptor has an API backend as well, where you would have to log in and, for example, manage the toolchain that you have. And it's mainly about the user login, because last slide I mentioned that there could be some form of forward registration. So there might be third-party vendors which have tools which might require a registration, and the ioRaptor could forward this registration.
Yeah. So here's Edgar. So we want to invite also third-party vendors to connect with the ioRaptor, both on a open source but also on a commercial license model, and work with us further in the different setups and needs of your company. So to give a vision of an possible integration approach, the opportunity for you is that with your existing models and existing products, existing development tools, you can integrate with the ioRaptor. So it works like for both sides on a kind of distribution model. Integration points are, and this is something where we're looking at it, installation software, installation scripts, Git, documentation, and forward registration. And our idea is to have the first integrations to be started in February. We're testing out and we're working with different vendors. And also the opportunity is to have a white label solution. So this means is that from a user perspective, you have an environment which is familiar to you, and from a third-party perspective, you have the opportunity to add your specific elements to it, so you can have a blended solutions for your specific developers. One of the examples here on the right side, we see a lot of blue. We're working with different major software companies who were working with us also with a specific menu set, which is targeted at their specific developer groups and developer use cases.
Yeah, thanks, Edgar. So, small typo. Of course, the white label solution is planned for mid of next year, so 2018, of course. So, the right diagram shows the white label mock-up, but we